Hi everyone. In this video, I'm going to go over another capital budgeting technique known as net present value, NPV. Okay? Net present value is oftentimes better than the payback period simply because you're going to look at the present value of the cash flows. Okay, what I have right now is a table. So some of you, if it's been a while, you might not have seen factor tables. Okay, so there's present value of 1. Okay, that's one lump sum. There's present value of annuity. That's the same amount every period. Okay, so when you read these problems, you want to analyze, are they looking at one lump sum payment? Well, that would be the present value of 1. Or are they looking at the present value of consistent cash flows, equal cash flows? That will be the present value of an annuity. There's also future value tables. Just ignore those. Okay? All right, so let's look at the problem. Here's what it says. Woodsy Music is considering investing $625,000 in private lesson studios that will have no residual value. The studios are expected to result in annual net cash inflows of $90,000 per year for the next 9 years. Okay, so it's $90,000. Assuming that Woodsy uses an 8% hurdle rate, what is the net present value of the studio investment? And they're asking, is this a favorable investment? Okay, so they're saying the net annual cash flows are $90,000 per year for 9 years. I need that number. And then I also need the 8% hurdle rate. Okay, so I am going to find the present value of the annuity table. Present value of annuity. Okay? And here's what I'm going to do. So for the top of it, the present value, okay, those are the percentages. Down below, over to the side, are the number of periods. Okay, so it said 9 years. So I take my finger, I go down 9 periods, and then I trace it across, and I stop when I come to 8%. Or I could have taken my finger for the 8% and then gone down and stopped when I got to 9 periods. So the correct factor for this problem is 6.247. That's how you do annuity tables. All right, so now I'm just going to put in the math. I'm going to take 90,000, which is the amount of equal cash flows that will occur every year. And then I'm going to multiply it by the factor that we just determined. Take your time when you write down the factors. Make sure you do not transpose a number. 6.247. And you just take 90,000 times 6.247, and that equals 562,230. Okay, so the present value, the total present value of this 90,000 is 562,230. Now again, make sure you set up your equation properly. Total present value is the number on the top minus the initial investment. So the total present value is 562. Please take good notes on this. When test time comes up again, you want to understand. 562,230. Now you're going to subtract out your initial investment. So I go look at the problem. What's the initial investment? It was 625,000. Okay? 625,000. And I'm going to subtract that. When I do, the net present value of these two numbers is negative. Very important. Put in your negatives. Negative 62,770. Well, guess what? I'm not going to accept it. Here's why. If the net present value is 0 or greater, I will accept that investment. So sometimes some of the questions are tricky and it ends up being 0. You would still accept it. okay, because it's not negative. If net present value is negative, however, like this one, do not invest. So we will not invest in this, what were they buying? Sorry. Anyways, they're purchasing a they're purchasing a studio. Okay, so they're purchasing a studio. So no, they are not going to do this because in this case it's negative. All right, so it's not favorable. All right, and that's how you do net present value. Get in the lab.